Okay, I'm back in pre-calculus, geotrig, college algebra, trigonometry, whatever you want to call the class we took last year. We dealt with what's called the difference quotient, and we have that specific structure, and you'll recognize that as what we did last chapter in finding slope of the tangent line, right? We had this difference quotient. We did the limit as h approached 0 on those problems from chapter 2.6. In chapter 3.2, we have the definition of a derivative, which is right here. And you'll notice that this right here is what your slope formula was in last chapter, but now instead of calling it slope, we got this new notation, this, get a highlighter here. We got this notation here, and that is what a derivative notation is. So anytime you're asked to find the derivative of something, that is a notation that you can use to represent derivative. And this is read f prime of x. So typically that f parentheses x is an f of x that we have. This little apostrophe symbol is read as a prime, so f prime of x. Eventually we're going to get the second, third derivatives, be f double prime, f triple prime, so it would just be 2 apostrophes, 3 apostrophes like that as we get to higher order derivatives. That's later in the chapter though. But the definition of derivative is simply the same as the slope formula we've been dealing with recently. And instead of calling it slope, we're calling it the derivative. And you'll notice here the first derivative, which is what this is, of a function f prime of x is the slope of the tangent line. So we found the definition of slope last chapter, 2.6, and now I'm telling you slope and derivative are the same thing. So the tangent line is the same as the first derivative at any given value of x in the domain of the function. So what we did in chapter 2.6, finding the slopes of the tangent line, is what we're going to do in chapter 3.2, finding the derivative of the equation. All right? So with that in mind, if we're given a problem such as this, if f of x equals x cubed minus x, find f prime of x. Okay. Again, back in 2.6 we said find the slope of the tangent line at any given value x. If we look at our definition of derivative, f prime equals the limit as h approaches 0 of f of x plus h minus f of x all over h. It's got the same structure we had in the last chapter, so I'm going to do it the same way I did in the last chapter. The function itself is defined as x cubed minus x. That's what goes right here. What I don't know yet is what f of x plus h is. So I want to take that function and establish what f of x plus h would be. So if I replace the x with x plus h's, like so. And you'll notice that we have an x plus h to the third power. That's, again, the Pascal's triangle scenario. If I just build Pascal's triangle real quick, 1, 1, 1, 1, 2, 1 on the third line, 1, 3, 3, 1. Again, adding up these two numbers, get the number below it. Adding up these two numbers, get the number below it. And 3 is the power we're dealing with here, so 1, 3, 3, 1 is our sequence. So for this part here, I'm going to take 1 times x cubed times h to the 0. And we take the Pascal number 1, we take the x to the highest power, we take the h to the 0 power, put a plus sign, next Pascal number is 3, we go x squared h to the first, next Pascal is 3, we're going to have x to the first h squared, and the last number is 1, and we're going to get x to the 0, h to the first, or sorry, h to the third. One thing to be cautious of here is this whole expansion is only that bit of it. There's still this minus x plus h going on there. A lot of times people forget about that. Just be cautious that as you're expanding some binomial to a power that you don't forget about the rest of the polynomial. So if I distribute that minus through there, it's going to be minus x minus h at the end of this thing. So all this here is the expansion of my binomial cubed, and this here is simply minus x plus h distributing the minus sign through the parentheses. So altogether, my f of x plus h If I simplify each term, 1 times x cubed, 3 times x squared times h, 3 times x times h squared, and 1 times h cubed, minus x minus h. In the interest of having room to work, I'm going to just shrink this a little bit. You guys can do that on your paper too if you want to. I'm just going to shrink that up. So all my work is there, but I'll have to move around. All right. So now, looking at this definition derivative we're trying to do here, f prime of x should equal the limit as h is approaching 0 of f of x plus h goes here. That's going to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x minus h. We're subtracting f of x, and f of x is this expression. So if I'm subtracting these things, it's just going to subtract each object changing its sign. So it's going to be minus x cubed, and it'll be minus x will be plus x. And then the last bit of the definition says h goes in the bottom, so I'm going to put h on the bottom. If we were to attempt a direct substitution right now, we'll get some x stuff on top, we'll be divided by 0. We can't do it. It gets us to possibly infinity, and we don't know. So if I were to then simplify, I should expect, in polynomial land, I should expect that the objects in f of x should be subtracted. So the objects in f of x are in this. We're subtracting the objects in f of x there. We should see opposites every time. So x cubed minus x cubed cancels. Minus x plus x cancels. If that cancellation doesn't happen, chances are you forgot to distribute a minus sign over here. So be careful that if there aren't the opposite signs like that, check to see if all the signs got changed. The remaining terms, negative 3x squared h, 3xh squared h cubed, and h all contain the letter h. We can then reduce by h, so f prime of x is still a limit as h approaches 0. If I divide everything by h, I'm going to get 3x squared plus 3xh plus h squared minus 1. H on the bottom becomes 1, divided by 1 doesn't matter, so I'm going to write it as a polynomial structure there. Be careful that only the h to the first powers become non-h terms. H squared became h to the first, h cubed became h squared. So now when I substitute h equals 0, the direct substitution in for all the h's, the things that don't contain h are left over, the 0 terms go away. So the end result of this is that f prime of x is going to be 3x squared minus 1. The directions are to find f prime of x, so that's the end of this problem. Going forward, that equation represents the slope of the tangent line. So if they went on to say, find the slope of the line when x equals 4, change x to 4, work it out, and you'll find the answer, what the slope is. Or find the slope when x equals 0, because 0 you get the slope. So again, that's the purpose of the derivative, is to find the slope of the tangent line. We'll be using it for other stuff down the road too, but its main purpose is slope of tangent line. It's just a formula to come up with that for any equation